Let me know if okay. Kind of marginal. So let's just say you have a better one. Should we pull? Oh, this is not good. This is a wall. So we don't write I've done that before. It's probably still there wherever I used to teach. Oh, here. So anyways, yeah. So let's see. There were two major categories of statistics that we covered. There's, I'll give you a hint. One of them begins with a D. Descriptive statistics. And the, okay, so the thing about descriptive, you're just describing the sample. For example, if I counted how many students are here, how many males, how many females there are, that's descriptive. The other kind is something more than that. It's called, and oh wow, you remember all this stuff. Okay, that was 2 weeks ago. Well, you probably have your slides up. Inferential is used, it's going beyond what's here in the classroom. It's you're trying to make an inference about what's so in the population based on the sample. So if I got your stats and go, okay, it's X% male, X% female, and I was using that to make an inference about graduate students in general, are they more likely to be male or female in all graduate students across the U.S., that would be more of an inferential statistic. And so if I was trying to make a prediction about are graduate students predominantly male or female, well, if I was trying to make that estimation based on this sample, I would say, hell, there's hardly any males who are in graduate school. So that's the difference between descriptive and inferential statistics. Inferential statistics can be used, also examine relationships between two kinds of variables. One of them being the, begins with an I kind of variable. Very good. And the D kind of variable. Dependent variable. So what I'm doing is I'm collecting data on a sample to determine whether, is there differences between men and women on their interests in the social sciences? That sounds so boring, but yeah, that's an example. Okay. So that'd be an example of an inferential statistic for which I will do a chi-square test because the two variables are categorical. So like gender is male, female, interest in this topic is yes, no. That would be an example of a chi-square test, which is a kind of inferential test. Do you remember what kind of test you would, for a t-test, what would I do a t-test for? To compare two groups on some kind of variable that is, begins with a C. Continuous. Can you give me an example of variables for which I would run a t-test, an independent samples t-test? Pardon me? Age. So I could, well, if I wanted to say, are these two groups different on age? So let's say I was looking at, do medical school students differ from physician assistant students on the age they are when they get in to school? That would be a sample of a t-test, two sample t-tests, independent samples. For example, I know for physician assistants, the average age is 27. For med school students these days, it's 24. So that's probably a statistically significant difference if I have a large enough sample size. Oh, speaking of which, sample size does play a role in whether something's statistically significant, right? So it's always good to have a large sample size because when you have a large sample size, the results are more reliable. Because when you have a small sample size, it could be that you've got some very unusual person who's not representative of the sample. A few people who aren't, they're just kind of what you call outliers. That could really influence the results. But if you have a larger sample size, those messed up outliers, just joking, they don't influence your results as strongly, right? Yeah. So there's that. We covered the chi-square test, the independent samples t-test. What's another one that we covered? So we talked about chi-square. So chi-square is one, t-test is another. Correlation coefficient, that's where you would have one of those graphs. Where you have one variable on the x-axis, another variable on the y-axis. So you could have something like anxiety and performance on a test, like test score. Test scores, like let's say you're taking a GRE. GRE, I know. So what do you think the relationship is between anxiety and test scores? As anxiety goes up, what happens with your test scores? Does it seem like that? Maybe, let's see. But you know what, honestly? So that would be a negative relationship, what you're talking about, you know. If one thing goes up, the other goes down. That's an example of a negative relationship or a correlation coefficient. But if it's kind of interesting, sometimes things don't work perfectly up or perfectly down. I'll be honest with you, this is what happens with anxiety levels and test scores. It's not a direct linear relationship where you have a straight line relationship going up and down. It's actually like that. Does anybody have a reason why? Why do you think it would be more like that? So in case some of you can't see it, it's kind of like an upside down U-shaped. That's what happens with the relationship between anxiety and test scores. Why do you think that would be the case? Yeah.
Is it possible that was like the right amount of anxiety you want to learn in your exam?
Yes, exactly. But if you don't have enough anxiety, okay, so yeah, so if you don't have enough anxiety, then you're like, hey, cool, dude. No, I'm just thinking about what I'm eating for lunch. I wonder who Facebook friend requested me, or well, you're too young for that. You probably did Snapchat or whatever, right? So you might be thinking about those kind of things. But then if you're too anxious, then you black out, freak out, don't even know your name, right? And so then that can make you go down too, right? Just so you know, sometimes things aren't a perfect linear relationship, and there's other kind of tests that can test for this kind of relationship that goes beyond what the correlation coefficient. So there's other statistical tests you can run for that kind of stuff that we're just not covering. You may or may not cover it in grad school, just so you understand that. So the correlation coefficient, the last one that we didn't cover was the ANOVA, which is comparing 3 or more groups. So it's basically like a t-test with more groups involved. So it's like comparing apples, oranges, and bananas and their caloric content. Something like that. So that kind of covers those things. With all these inferential tests, there's a p-value associated with them to help us determine whether we say that there is a significant finding or not. Do you know what that p-value is, that magic number? 0.05. And don't get it, not to be confused with 0.50, which is 50-50. It's 0.05, which means there's only a 5% chance that given the data that we got from the sample, that there's no relationship between these two variables, or there's no differences between these two groups of people on this outcome dependent variable. Anything above 0.05, we'd say, yeah, it seems like these groups are kind of similar, that there's not a difference between them, or there's not a relationship between anxiety and test scores, or whatever you're looking at. It's going to vary from profession to profession. When you get into pharmaceutical kind of stuff, they're far more conservative, and their p-value might be 0.01 because they want to make darn sure that this drug is efficacious before they even put it out there on the market. Because they don't want 5% of people to say this didn't do me any bit of good. You know, so they make their results even 0.01 for it to be significant. But if you're doing a more exploratory kind of study, we might say, somebody try to say something on my hearing things. Oh, okay. 0.10 or higher, you know, for a more exploratory study where I didn't have a big sample size and that kind of thing. You know, that's what the criteria might be for that. I know we kind of hurried through, let's interpret an article, and, you know, we did our best, but it was really quick. And so I don't know if you had the full flavor of that. So today, you could do the same thing, but in more detail and perhaps with an article that you like. We could do it one of two ways. I mean, we could have people just come up to me as needed, or if people want to present, I don't know. What's the best way to do this with you? Any suggestions? Just like come by and ask?
So are they going to read an article and find statistical, you know, features, or?
We could. I mean, they each have their own articles. You have your own articles by now, right? And have you kind of pawed through them yet much? And have you kind of made sense of them? Or is it, or are there any people, okay, so how many of you are pretty clear on what the heck is going on with your article? Okay, nobody is. That's fine. That's an okay place to be. I mean, we could, because then, do all of you have each other's articles or not? No, okay. So if that's the case, we wouldn't be able, hey folks, look at this article and this is what we see and da-da-da-da-da. So that wouldn't work, if, you know. So I think the best kind of thing to do is maybe come and troubleshoot with me, and then I'll try to give everybody the best time possible, and then maybe for the last, I don't know, 15, what we could do is do that for an hour, and then for the last 10 minutes, I can talk about the common things that I've seen that people have been confused on, and we could cover those. Maybe I'll even allow 15 minutes for that. So we could do that for now, between now and 6:45. Does that sound like a plan? I think that's the best thing given the circumstances. So let's just do it that way. And then use this box if you want to as a guiding sort of reference. I mean, you're not obligated to fill it out. You don't have to turn this in to me, but it could potentially help you if you feel like it does. And you know, it's something I just borrowed off the internet. And good things to think about for a given article as well. So it makes you, you know, the good thing I like about these questions, they make you think beyond what the author says. It makes you realize that, hey, I have a mind of my own, and I can decide whether what the author says is fully, you know, do I buy into fully what they say, or do I feel like there's alternative explanations to their findings, or should they have done something differently? That kind of thing. So anyways, feel free. Come up as needed. Don't be shy. There's a seat right here waiting for you. If you want to hold hands and come up together, there's even 2 seats.
The p-value, the numbers, I did something that makes